Welcome to the Animal Training Academy podcast show. I'm your host, Ryan Cartledge. I know that you're here because you want to master your animal training skills using a force-free approach. And to handle the variety of challenges you face, you need a broad knowledge and experience base. The problem is, we all get stuck and hit rough patches in our training, which can leave us feeling overwhelmed and helpless. Our mission since 2015 is to empower trainers just like you. The Animal Training Academy has helped thousands of trainers globally to develop skills, gain confidence, and positively influence both animal and human learners. Here's how we can do the same for you. Sign up for our membership waitlist at www.atamember.com. Register when our doors open email arrives and start growing your training skills. Build impactful training practices benefiting you and those you train. So join the waitlist at www.atamember.com. And while waiting, enjoy this free podcast show. We want to see you avoid embarrassment, overwhelm, and burnout. Instead, we want to see you build resilience to setbacks, get more organized, and grow your training skills and knowledge. In short, we want to see you enjoy confidence in yourself as a trainer and lead a fulfilling life, positively impacting the lives of the animal and human learners you work with. But we will start today's episode where I'm thrilled to welcome back to the ATA podcast show the wonderful Rick Hester and the renowned Dr. Susan Friedman. Rick Hester is the curator of behavioral husbandry for the Cheyenne Mountain Zoo in Colorado. He's been with the zoo since 2006, working with a myriad of species from penguins to African lions. In 2015, he began collaborating with Dr. Susan Friedman, diving deep into the world of behavior analysis and its significance for animals in human care. Rick is also an adjunct faculty at Colorado State University and a consultant for Susan Friedman's Behavior Works LLC. Dr. Susan Friedman, on the other hand, is a professor emeritus in the Department of Psychology at Utah State University. With her work translated into 17 languages, she has consulted with zoos globally. Although she works with all earthlings, she's been instrumental in shaping the understanding of animal behavior in our industry. Her influence and ripples spread across the globe. So without further ado, it's my very great pleasure to welcome Rick Hester and Dr. Friedman back to the show today for the third time. Thank you both so much for taking more time to come and hang out with us at Animal Training Academy.
Hi.
Hi, thanks for having us.
Well, absolutely thrilled. And listener of the show, today I'm genuinely excited to delve into a topic that might be new to some of you, freeing up the operant. If you're scratching your head wondering what on earth is that, or if you've heard of it but aren't quite sure what it entails, don't worry. We're going to unpack this concept, dive deep into its origins, and more importantly, explore how understanding it can be a game changer in your practical work with animals, ultimately enriching their lives. The concept of freeing up the operant has its roots, from my understanding, in the 1930s. Rick and Susan, can you shed some light on the context of the research from this time and how it laid the groundwork for what we're going to talk about today?
Yeah, I can speak to that. And Rick, you join in wherever I'm leaving gaps. It's something we've talked about a lot. It makes sense to me to think of it as coming from the late 30s, because that's when Skinner first wrote Science and Human Behavior. And if there was any one book to read, that would be it. I would highly recommend it for your book reading club. It sounds like it would be intimidating reading a Skinner book, but it is really delicious, and it will fill many gaps, I'm confident, in your understanding of how behavior works and where the science and technology of operant learning really gave rise from. And so when we talk about it really having its origins with Skinner, it is in contrast to the methodology of the day, which would be Pavlov's, where he had dogs secured, strapped up in his experiments in order to measure their reflexive responses to conditioned stimuli, and also perhaps to Thorndike, who had cats in boxes and then measured the speed with which they learned to open the latch. So in both cases of those predecessor behavior and learning scientists, animals were restricted. Their behavior was restricted by the experimental preparation. And when Skinner started doing his work, he took a very different turn in how he set up his experiments, and everything fell from there. He would place an animal, a rat or a pigeon, as all of you know, just following the logical sort of story, into a chamber. And the animal in that chamber was free to do whatever it chose to do, given that environment. So they were free in the sense that there was no preceding cue or eliciting or evoking variable from the experimenter. And so it was free in that sense. They could walk around the chamber. They could spend time grooming, which they often did. They could stand there just resting. Or if they operated the lever in the case of a rat, or pecked the key light in the case of the pigeon, then they would be reinforced with food. And so those behaviors, the pecking and the lever pressing, those two operations would be increased in rate, frequency, and they measured rate, frequency over time. So that's, in that sense, they were operators, and that's the origin, as I understand it, reading Lindsley, is the origins of the concept of a free environment and an operant class of behavior. So they don't peck exactly the same every time. They don't push a lever the same every time. So we're really not talking about a single behavior. We're talking about classes that we call pecking. That includes a variety of pecking topographies and lever pressing. So that gives us our two anchoring concepts: free in the sense that the animal is free to behave as it chooses, given the environment it's in, given its behavioral history, and given its genetic tendencies. And they're operators when they use the operandum, the lever or the key light, and then the reinforcer strengthens that. Out of all the things they can do, that is selected by consequences. So free operant environments are unconstrained compared to what would be considered a discrete trial approach, where an agent, that is a trainer or researcher or teacher, delivers the cue. So we control the onset of the behavior with our cue. The animal operates with behavior, but we control the criterion for which reinforcement will follow, which we also control. So in that ABC model that we've explored to such amazing success, blowing the lid off demonstrations of what animals can learn, with discrete trial training and positive reinforcement, we consider those not free operant environments to the extent that we cue, we set a criterion, and we reinforce. So, of course, these words are, I don't know, are they metaphors or, adjectives and adverbs? We give them meaning by how we choose to operationalize them. So we're not talking about free in the sense of soul's free will, but we're talking about the freedom to behave as much, as fast, as slow, or not, given an environmental arrangement. And then, Rick, I wonder if you would pick up on ideas that I really enjoyed discussing with you about how animals under training preparations are only covered for such a little part of their day.
Not only are they restricted in a training session context in the ways that Susan just described, their behavior is restricted by our delivery of the cue, our criteria for reinforcement, and our reinforcers that we're choosing to use. Those discrete trials represent a very small amount of an animal's day, generally speaking, especially in the zoo environment. That might occupy 15 minutes, 20 minutes, 45 minutes at the upper end of an animal's day, 24-hour day. So like Susan said, we've used that arrangement to lift animal well-being up in amazing ways. They are enthusiastic, voluntary participants in their own medical care and their husbandry routines in ways that I certainly wasn't seeing regularly happening 15 years ago in that profession, our profession, and now you see it all over the world, and it's amazing. But what I've come to observe is that it doesn't represent a lifestyle because it occupies too little of their life to really be a lifestyle. So when all of our attention is on our discrete trial training arrangements, in between those few opportunities, the animals are waiting. They're waiting for the next opportunity to engage in a discrete trial session. And this discussion around a free operant arrangement, I think that's the arrangement that fills the gap between those discrete trial sessions.
I remember when we were in Australia, Rick, and this is in May, listener of the podcast show, Rick was in Australia, and I met Rick in person at Tim Sullivan's enrichment workshop that preceded our Australasian Animal Training Conference. And Rick was working on his computer, and I had a conversation with him, and he said he was adding to his presentation for the next day, and he started to talk to me straight away about discrete trials. I think that was one of the first conversations we ever had in person, Rick, was about discrete trials. Does that suggest, and leading into and mixing with this concept of the free operant, does that, my experience there that I just relayed to the listeners of this show, suggest how much this is in your thoughts at the moment and how important it is to your current work?
Oh yeah, this is where I'm focusing the vast majority of my attention, working at the zoo and all the thinking time in between, considering how do we engineer free operant environments for animals in human care, environments where the antecedents and consequences are available. They're not waiting for keepers, trainers, teachers, experimenters to deliver them. They're available, and they can choose how and when and for how long to interact with those aspects of their environment.
Rewinding now a little bit, and with an aim to deliver information to the listeners of this episode in a chronological order. We started in the 30s, and Rick, you sent me an article by Ogden Lindsay written in the 90s, was it? 96? Anyway, it was about...
I think 95 or 96, yeah.
But it was about the... In Ogden Lindsay, and this is my interpretation of Rick said it took a couple of times to sink his teeth into, so you tell me if I've interpreted how you interpreted it. But it was about how the free and operant concept was one that was prevalent in the 1950s in terms of laboratory studies, but has kind of faded from use since that time. And considering there's been 20, 30 years since that article was published, I'm not sure what's happened in the interim. But how does this free and operant concept in the scientific community, in the academic community, starting in the 30s, from the article that I read from Ogden Lindsay, heavily talked about, utilized in the 50s, has it kind of faded from the focus in the academic world in applied behavior analysis, or have I read that article differently than what I was actually trying to say?
Yeah, I think that's accurate. That's what Lindsley in that 96 paper was describing, was that there are so many forks in the path, and you follow the need. And the need was to have a teaching technology that would allow teachers to build functional skills that would help children with special learning needs succeed with the skills they would need to succeed, living their days. So it might be something like, pottying and hand washing, or color identification, or item selections, groupings, and those kinds of life skills. And that lent itself to that discrete trial approach, and with it a discrete trial measurement approach. So now we could measure not how what an individual learner does with their free operant repertoires in a given environment, but how their behavior, their life skills, their goals and objectives were met in that ABC kind of trial. So we talked about percentages correct, and that measure of rate, of frequency over time, became less common, although it's very much alive and well, and having important results in the precision teaching community. Precision teaching being, maybe you have met with Rick Kubina. I've forgotten. He'd be a good person to bring on. One of Lindsley's students, and Lindsley developed this other way of teaching that was more like a free operant approach, where you did 1-minute time samples, you let children read freely, and you counted up how many words they were able to read in a minute, and kept building that speed towards fluency. So that precision teaching strategy represents a free operant approach more than not, compared to sitting at a desk and having a child repeatedly sort red into red and green into green blocks or something like that. And I think that there's always such a tendency, when a new idea or an old idea comes back again, people are ready to hear another component of how behavior works, that people drop everything they were doing that was successful, and they run to pick up the new thing, as though they are mutually exclusive. And one thing I wanted to make sure that we said was that we're not saying that discrete trial training isn't the right way to train a dog to wait at the door without bolting out the door, or to teach a giraffe to curl its foot on a block, or to teach a child, some elements of reading. But what we are saying is that there's also this other perspective, and with it comes along its very sharp tools that are successful as well. So we want to envision doing both. The question is, when is discrete trial training the right procedure? And are we providing sufficient free operant opportunities for animals to do what they're built to do, which is to go out into, the savannah or the jungle or wherever, and behave freely within that, operate freely within that environment for their reinforcers. So this really adds, I think, an important spin on how we provide for our animals. For example, your new cat environment sounds very much like a free operant environment, that you can open the door and your cat can safely, because of this expansive netting enclosure you've provided, can experience being naturally shaped by that environment to hunt and to stalk and to hide, behaviors that are harder to see and arrange for in your house. And in the zoo, it might mean as Rick will explain with more detail, providing bigger wallows and a constant parade of trees with bark in order for elephants, when they're done training a medical behavior, to then be turned out into this environment where they can behave freely, choosing what to do, when, how much, how little, how fast, how slow. So I don't know, Ryan, is it a good time for Rick to talk about the free operant environments that he and his colleagues have created at Cheyenne Mountain?
It is. I have one more question, though, that I think might tie it together and kind of keep us chronologically where I was originally heading for my question before that. And that is, and tell me if it's not relevant, because that's also fine. In the Ogden Lindsay article, I learned about 4 free operants, which relate to some of the things you're just saying, I believe, Susan, about when, how long. For our listeners who might not be familiar with these, could we delve into what the 4 freedoms are and then proceed into Rick's fantastic examples, which I'm super excited about sharing?
Sure. That's a good idea. Sorry to jump around into...
No, absolutely fine.
Rick, you describe that.
Okay. So yeah, Ogden in that article described the title of the article is the 4 freedoms of the free operant, I think, or something along those lines. And he describes 4 freedoms that this arrangement provides the learner. The first is the freedom to self-present or to self-pace. And this one eluded me the first couple of times that I read the article, but it's come to be the one that I might be the most interested in, especially when considering a zoo environment. But this is the freedom to start and stop and start over. And it doesn't require the antecedent to be presented by the teacher or the experimenter or the keeper. The antecedents that the behavior rely on are present in the environment, and the animal can decide when to go interact. When to go interact with that stimulus and produce whatever reinforcers are available. Anything to add to that, just that description of the idea of self-presenting, Susan, before we move on to others?
Yeah, I just, the contrast Og talks about in the article, if you think about presenting flashcards to kids and how their rate of responding to the flashcards double when they flip through the flashcards versus when someone else presents the flashcards and they respond to the person holding the flashcard. So, I mean, that's a pretty phenomenal and interesting, description of what the freedom to self-present, to hold your own flashcards and to go through them, reading the words you're learning at the pace you're comfortable doing, versus having a teacher for whom it is reinforcing to present those flashcards for you.
Yeah, the flashcards is a great example. And in the zoo environment, we present most of the flashcards, generally speaking, and the animals are waiting around for us to come by and present the next flashcard. So it's very interesting to think about how can you arrange an environment where those flashcards are freely available, and those animals can choose to go and interact with them at their own pace with their own timing.
Have you used the metaphor of flashcards in the zoo setting before? Because that resonated with me. I liked it.
This is the first time that I've used the metaphor of flashcards to describe a zoo setting. Yeah.
Well, we'll see if you continue to use that in the future or not.
But we connect those dots between humans and non-humans seamlessly. It just,
Absolutely.
our eyes are not even really very attuned to that difference.
Yeah.
I loves it. All right.
Yeah.
Anything else to add on self-pacing?
I don't think so.
And well, I'm curious, Rick, what changed from the first time you read the article to now to mold and evolve your preference and focus on this freedom as opposed to others? Do you have an answer for that, or have you thought about that?
Well, my introduction to this concept comes after some work where we provided a free operant arrangement, but we didn't know about a free operant arrangement. So it was unpacking some work with elephants that we were really excited about, the behavior changes that were produced. And Susan was with us along the way, and she and I were writing up an article about the work and discussing what about the arrangement produced these results. And she connected the dot to the free operant concept that I had not come into contact with at all before. So since then, I've spent a lot of time reading and rereading Ogden's work and considering what that looks like. So somewhere along that path, the freedom to self-present has become more and more obvious to me as I observe animals in a zoo environment and recognize that they tend to have very little control over when events occur. We decide when we present the flashcards, and some of the work that we've done recently has given more of that control back to the learner, that animals are able to decide when and what they do. So it's just become more salient over time, a combination of reading and thinking and talking with Susan, and then actually observing animals.
So in relation to the cat example at my house, which Susan mentioned earlier, which for everyone listening is when our daughter was born 3.5 years ago, we noticed one of our cats doing behaviors in the class of hunting our chihuahua, which obviously is undesirable. And my flashcard was chasey toys, a pole with a string on it and some feathers which twirl. There's a specific toy called Da Bird, which Tilo, my cat, loves. Take it outside. We would hunt that for 15 minutes, and we could see a change in behavior in the house with regards to behaviors in that class of hunting. But now we've modified our whole front yard, and the cats can go outside into a large space which is open, but they can't get off the property. And this is brand new. So over the last few weeks, Tilo's been sat here with me in my office with my office door open, and she comes and goes over a period of 4 or 5 hours because there's flashcards the environment's providing in terms of birds, and she hasn't killed, no birds were harmed in the making of this podcast. She has not caught a bird thus far, and hopefully it stays that way. We don't want any birds to die. But the flashcards are being presented by the environment, and she is choosing, she is self-pacing when, you can see the stuttering in my words, listeners, that I'm, like you, probably trying to grasp these ideas. Is that relevant to what you just described?
Absolutely. That's the arrangement. That's the arrangement we're going for. And then to echo what Susan was clarifying before, discrete trial training has a place, absolutely, in these animals' lives. And so you can use that. You can use that arrangement to teach your cat the skills it needs to participate in medical care and to come in from that catio at the end of the day, if that's a requirement, and whatever other behaviors are necessary to be successful in your home. But at the end of each of those discrete trials, there's a free operant environment available. So we're coming to ask at the end of a training session, what am I leaving this animal with? What is the freely available environment providing to them when I walk away for the next 3 hours before I come back again to offer another opportunity?
And from that discussion, we've come up with this phrase that we use a lot now to remind each other about how important, or all of us, how important it is. And that is that the animals are waiting. And we don't want animals that spend all their time waiting for the next training session to occur. We want animals to enthusiastically come forward for training when we show up. And when we're finished, we want them to enthusiastically haul out to an environment that is at least as reinforcing to operate within. So we say that a lot to each other, as we're working through this, is, the animals are waiting. And I think that's the problem we're trying to solve.
Love it. I could talk about my cats all day, but let's move on to the other three freedoms, please.
The second one that Ogden calls attention to is the freedom to form responses. So to think about a discrete trial training session, in contrast, we set the criteria for producing reinforcers. We select for the topography or the intensity or the duration that we are shaping. In a free operant arrangement, the animal is free to form their own response. And Ogden points out that they often come up with more efficient ways to complete the task than we would. The lever is present. It has to be depressed a certain distance in order to trigger a switch that delivers the food. That's the only requirement, is that the lever is depressed. How the rat depresses the lever is not selected for. So it can use its right paw, its left paw, both paws, its nose. It could sit on it, whatever, of these all those various behaviors that depress the switch are there to be performed and produce reinforcers. So they're not restricted in the way that they are in a discrete trial training session where we select for the criteria. And the goal we were chasing originally, before I had learned about the free operant arrangement, we were looking to provide environments that produced varied behavior for varied reinforcers. And the free operant environment does that. And this is one of the ways that it does it, is that they're free to form their own responses. The elephants are free to interact with the mud wallow in endless ways. We're not selecting for sitting down topography. They can sit and lay and roll and throw it on themselves and smash their faces in it, or just walk through it, or there's just so many responses available to them. In contrast to a training session where we select the criteria.
Awesome. So we've got. Do you want to add anything, Susan?
No.
So we've got the freedom to self-pace, the freedom to form response. What's the next?
Next, the freedom to repeat responses. So Ogden points out that they're free to repeat many times to each signal. And maybe Susan I think he has a flashcard example that you might recall, or another good example of that. But there's not just one response per cue presentation necessarily.
Okay.
Did you have a flashcard example?
I don't have one ready. Sorry, guys. But I think that one is self-evident, that when you have the freedom to repeat, that's a major component of building fluency. And how much repetition you do is best determined by the repeater rather than the trainer, if possible.
So with a flashcard, it would be if you're learning to speak new words or and you got to car, it would be, rather than moving on to cat, you would stay at car and repeat car as many times as you wanted to repeat car before moving on to the next one.
And you see this in children, and I think they're a good model for what we can provide to animals. You take a small child, they're always grabbing from the parent or the teacher the toy. They want to put the lid on the can. They want to take the ball and toss it. There's this push and pull where the adult is trying to control how the child interacts with an item, and the kid is trying to take that item and have their freedom to self-present, to have their own pace, as much repetition as they want, and so forth. And it's sort of a funny description of modern interaction with children, that we are hovering over their behaviors and restricting how they do things, and not allowing the 4 operant freedoms. And Rick will finish the other 2. But I think if you're looking for examples of what we mean by the concept, and you think about a child, there's so often a struggle for who gets to hold the item that they're working with. And really, a kid might want to practice shoe tying 100 times before they give up the shoe. or they might want to practice putting little plastic frogs into aquariums, 500 times before they're done with that. And so if you imagine us coming in and saying, we're going to do the frog thing once, we're going to do the shoe tying once, that is an obstacle to the free operant freedoms, which slows down learning and independence and creativity and all sorts of things.
I'm trying to think of an animal example where the trainer's trying to restrict repetition.
It's harder to come up with a non-human learner example because we've restricted these interactions we have to our training discrete trial approaches. So we're not observing them out in the enclosures where their free operant behavior should occur, given an environment that is stimulus rich with things to operate freely. So where we need to look for animals examples is when your cat is in the catico, and when an elephant is in the yard, or the bear is in the rock area, rather than when we're in front of them by the training wall.
Yeah, absolutely. And that was a big shift in the context that we are observing what animals do is what started shaking a lot of this loose for me. I was observing animals almost exclusively in discrete trial training arrangements. And I went looking outside of training for potential distant antecedent predictors of aggressive behavior that was occurring within a training session that we were all struggling to predict. And I did not find antecedent predictors that helped me understand the aggression in the training session. But what I did find is animals waiting for the next interaction with keepers. And that's what sort of put us on the trail at the Cheyenne Mountain Zoo team on the trail of observing animals in between those interactions with keepers and being able to see the impacts of that environment on their behavior.
I believe we've got one more freedom.
Yeah, the last of the 4 freedoms that Ogden describes is the freedom to speed responses, for the animal to respond as fast or as slow as they choose. And he points out that in laboratory designing the operanda, the devices that the animals interact with, that it was a challenge to design operanda that would allow the learners to respond as fast as they would choose to, if not restricted by the operanda needing to reset for the next repetition, that they would generally respond faster if they were free to do so than they would in a more restricted context.
So we've got the freedom to present or self-pace, the freedom to form response, the freedom to repeat, and the freedom to speed responses. Just to ensure that credit's given to where credit's due, are these, you refer to them as Ogden's 4 responses, are they 4 freedoms that have been defined by Ogden, or did they come from elsewhere?
I would say, and check me out on this, Rick. First of all, we would probably need another 6 months of reading to do a historical analysis of how ideas are revealed. I don't often think about finding the origin person because we're constantly building on what's come before us. So although Skinner may not have used the term free operant in 1938 to 1943 or something, clearly his shift from a restricted research preparation like Pavlov and Thorndike used to these chambers where behavior was allowed to unfold in these 4 ways, these 4 characteristic ways, was the result of his brilliance. And then Ogden was Skinner's student. And so he was also very brilliant. I got to know both of them as they were on the board of directors at the residential treatment center I was working at as an 18-year-old. And he also loved making words sticky. That was one of his characteristic approaches to disseminating. And so he comes along and he writes four freedoms, but and he thanks Gold Diamond profusely in that article for his work towards that. So I don't know that it really fits the culture of behavior analysts, maybe, or at least not Rick and mine's, to think about where the the first person to think up something and give them credit. The credit belongs to this line, this historical line that has been progressing since Skinner, with acknowledgments to Thorndike and Pavlov and Darwin. Where does it begin? So I think we're just happy to cite Skinner for huge ideas that were not on the table before, and then his students ran out from there.
For those of us in Australasia and who attended the animal training conference in May this year, we were incredibly fortunate to hear you talk about some of the groundbreaking work you've been doing at Cheyenne Mountain Zoo, Rick. Your examples of working with penguins and elephants were captivating. Personally, your presentation was one of the most impactful for me amidst a lineup of truly inspiring talks. The caliber was high. Therefore, I'm thrilled to have this opportunity to delve into these two examples now with you and for our audience. Could you kick things off, please, by sharing about the work that you've done there with your penguins?
Sure. Thanks for the praise. It was great to be there with you all and learn with you guys, and hope to be back in the not too distant future. With penguins, we have been exploring ways to free up the operant, specifically around eating. The sort of conventional way that zoo penguins are fed is at scheduled times by hand. They're fed dead fish by keepers' hands at scheduled times. And in between those times, they're often waiting near the location that the keepers arrive for the next feeding opportunity. And we've been exploring what it looks like. What does a free operant arrangement around penguin feeding look like? The arrangement that we've been testing for, I guess, a year now, probably, is to manage the penguin habitat like a reservoir, and to stock rainbow trout in that reservoir and manage a population of trout that are freely available for penguins to hunt and catch and eat. And we've arranged an environment that supports the trout as well. So the trout are able to evade the penguins, much like they evade their predators in the wild environment, and live out a full life in the penguin habitat. We have many trout that grow to be as big as penguins, evading penguins when they're small, and then the penguins don't really interact with them once they're large. But it has provided the penguins the opportunity to choose when they eat, or when they behave to eat, when they hunt, how they hunt, how long they hunt, how fast they hunt, when they start and stop. It's available in the environment 24/7. And it was that way from the beginning. So it's also interesting to think about how they acquired that hunting repertoire. They acquired it in a free operant arrangement. We didn't shape it in discrete trial training sessions. The trout were available, and then the penguins would get in the water and interact with the trout. The trout would escape the penguins. And over time, the penguins learned how to effectively locate, corral, catch, and eat the trout, working as a team. Actually, they tend to hunt as a group. And we measured their behavior at the beginning, the first presentations of trout. None of the penguins could catch fish. So they did behave to interact with fish right away. They jump in the water and they swim right up to the school of fish. and all the fish swim away. And then the penguins sort of just floating there now, no more fish. And I went back to see them 3 weeks later, and they were hunting effectively as a group. They were swimming fast, and they were taking sharp turns, and they were working as a team to corral fish, move them up to the surface of the water where they were easier to catch. They acquired that repertoire by interacting with this free operant environment, naturally occurring shaping. The longer they go without catching a fish, the more valuable the fish, the harder and faster they swim to catch the fish. And when they do that, they catch it. The environment selects for the increased speed or the working in conjunction with another penguin, because that's what produces the fish. So they became very skilled hunters in a free operant arrangement. And it was really exciting to see. And they spend significant amounts of time interacting with the environment in this way. On days where we stock the reservoir, stock the pools, penguins, we do 3-hour observations of the penguins to collect our data. So we're getting a sample that we think represents the whole. And so in a 3-hour observation period, on a day where we stock, the penguins, some members of the flock are hunting sometimes 2 hours and 40 minutes out of 3 hours. They're actively interacting with their environment in that way. And I had not seen anything like that before. In our efforts around environmental enrichment, I'd never seen lasting interaction like that, where animals were operating on their environment for hours, not waiting around for the next time that the keepers were coming with the fish bucket.
Mention the particular, when we say topography, that's not a common word. So I just wanted to say we're talking about the form of the behavior, what you see, them do with their beaks and their feathers and their wings and their feet, and the topography of behavior. So Rick, would you talk about the swimming observation?
Yeah. So
the breath. Yeah.
Yeah. Before there were fish, our penguins did swim. They would swim in sort of two general ways. One, they would swim on the surface of the water like a duck, and they would splash and preen feathers. Most of the penguins do that every morning, once a day, and the purpose appears to be clean feathers. The other way that they were swimming was underwater, to travel from point A to point B, and it's sort of a slow glide, coasting under the water. And then when they reach their destination, they're usually getting out of the water when they arrive. When what we started to observe when the fish were available is a much faster, more intense swimming behavior. And we also observed that they would take breaths a lot more frequently, which makes sense. They're working hard now underwater. Their body's using up oxygen. So that now they're sprinting underwater. So they take breaths much more frequently when they're hunting fish. And we have slow-mo video of them that we were able to watch closely. And we observed that now when they're hunting, when they breathe on their way to the surface, they exhale all of the air before they reach the surface. You can see all the air bubbles coming out as they're getting close to the surface, but before they breach. And it allows them to breathe in as soon as their nares hit the air, and they go right back underwater. They're maximizing their time underwater and their speed with this breathing pattern. That they never did that before, but the environment never required a breathing pattern like that before. The fish is swimming away fast. You need air, and you also want to stick with that fish. That the environment required that response, and so they learned it. But it's amazing to watch them perform those more complex, diverse repertoires that we didn't observe before, but the environment didn't require them before.
And this is so, for us anyway, it was so exciting. I mean, we spent a day reading up on how human swimmers exhale and bring in breath. And we were so excited to see how similar the behavior chain was to expel air before you come up and grab some more air and go back down again. But what's really exciting for me, I guess, as somebody, well, and Rick too, I know, but I've been doing it for a long time. People will say these are species specific behaviors. Penguins are born knowing how to swim. The environment elicits like a reflex. These swimming chains, these are inherited or fixed action patterns. And yet here we see such a clear demonstration that when the environment doesn't select for certain behaviors, you don't see it. So even if penguins have a higher probability of swimming in this way, genetically, they're not going to just bust out that reflex because they're in water. They need a reason to perhaps trigger the behaviors that give them access to those fish reinforcers. And they're penguins, so they're going to swim to do it, not fly or hop. That's the genetic, component to how they're going to access those fish. They're not going to come from the air like an eagle, pick them up with their talons, right? They're going to swim for them and hunt in the water. But without the environment giving them the opportunity to go for fish and then have catching being selected by consequences, you don't see these behaviors. So behavior is always the result of genetic tendencies, learning history, and current conditions. And this pervasive notion in our society that behavior is ever entirely the result of your genetics, like that there's a gene for exhaling before you come up. I mean, it's just not accurate as far as we know today, and as far as Skinner knew in 1938.
Now I'm excited to see what hunting behaviors Tilo the cat produces. And I think it's relevant that I said she hasn't caught a bird yet earlier. Rick, this end result that you've just shared with us, evolving, the current point of where you are in this project, that, am I correct to say, started as a training problem? You were presented with, from your management, a problem and a training solution was sought. And it evolved and continued and landed to what you just described. Would that be accurate? Or have I just jumped between two ships here in terms of the same enclosure species?
It's all the same ship. And if you go back far enough, the initial problem behavior situation we were addressing was that our penguins chose to spend the vast majority of their time inside caves, inside rockwork in the habitat. And we did initially try to solve that problem with discrete trial training. We taught the penguins to come out of the caves and take fish. And then we shaped for movement further and further away from the caves. Our goal was that we would bring penguins into contact with naturally available reinforcers in the pool system, outdoors on the beaches, and that those reinforcers would then maintain the behavior of coming out of the caves. And that was unsuccessful. We successfully shaped the pattern. We taught penguins to leave the caves and travel, 200 or 300 feet through multiple doors outside to the very other far end of their habitat and take food from keepers twice a day, every day, and they would all arrive and eat. And then at the end of the feeding, at the end of the trial, when we removed the opportunity for fish, the penguins would, as quickly as possible, return back to the caves. So our initial intervention actually revolved around the caves. We asked a question around what are the costs and benefits of doing anything other than standing in the caves, and we hypothesized that there were not enough caves, that the cost of leaving the cave was that you would lose your preferred location. We observed penguins not just spending time in the caves, but competing over preferred sections of the cave. And so our hypothesis was that if you left the cave, the cost would be that you would lose that preferred spot. Another penguin would move in while you were out, and the cost was what was blocking these other potential reinforcers from having their effect. The opportunity to swim, to go outside, didn't compete with the cost of the cave. So we renovated that habitat shortly after opening it, and rebuilt the cave system to make caves much more widely available, and also slightly less deep, which may have reduced their value to some degree. And that resulted in an increase in the use of the habitat. Penguins were going outside, penguins were swimming. So from that intervention, we moved on to discuss the way in which we feed penguins, which led us to the trout arrangement.
So, given what you've learned since that initial intervention of using discrete trial to get the penguins to move across large areas of their very cool sounding enclosure, which you went into greater detail of when you're in Australia, having the knowledge that you have now, learning what you have learned, if you were to go back then, what kind of and this problem was brought to you by managers at your facility. What questions would you be asking now? And if a similar challenge is brought to you, how has it changed the initial questions that come to your mind when thinking about interventions in these challenges, class of challenges that you come across in the zoo context? Does that question make sense?
Yeah. The most obvious question that I carry now since penguins is asking what is the cost of performing any particular pattern, not just what are the reinforcers for the behavior we see now and what are the potential reinforcers for an alternative, but what do they have to give up, or what will they lose access to by doing what we want. I didn't have an eye for that before the penguin work, so that's a big one. What about you, Susan? All this work is done in conjunction with Susan. So, we talk at least once a week for many hours and discuss all of these interventions.
Much to the surprise of our families, which we always thank and appreciate for. I'm just thinking that when you say your eye now, you ask a newer question, which is, what do they lose? What's the cost for doing what we want them to do? I just wanted to mention that it's because we're so fluent at asking, what's the cost? What can we deliver that makes it worthwhile to do what we want to do? What we weren't asking was, what do they lose when they do what we want them to do? So our eyes have always been trained on what's the reinforcer? How can we use bigger, better timed, better individualized, more effective reinforcement. And now this other question is, if they do what you ask for those reinforcers, but they're still not doing as you expect, what are the competing reinforcers for not doing it? And we can give a shout out to Gold Diamond, who made that question very, very clear. And Joe Lang, who, like dusting off the free operant concept, dusts off Gold Diamond's great contributions for animal trainers to consider. So that was a cool question. I also wanted to just mention how much thought from Rick and his colleagues, Jeremy Dillon, went into thinking about the welfare of the fish. So that's something that we haven't covered here yet, but that was a hugely prominent problem to solve. And Rick, maybe you can describe how the fish live and how their welfare is protected.
Yeah, absolutely. So right at the outset, and it was Jeremy Dillon who nudged me to join him really in pursuing changing the way we feed penguins. I was quite satisfied with the effects of the cave intervention, and ready to move on to problems elsewhere. And it was Jeremy who really said we are not done yet, and he wanted to explore something around feeding. So he's really, it gets full credit for the nudge, and then has partnered with me all along. So right at the outset, we understood, and our director, Bob Chastain, understood that maybe our biggest challenge would be addressing the well-being of the fish. So these are the ways in which we've worked to protect the fish. We have a fish holding habitat that is independent of the penguin habitat. That's where the fish live when they first arrive to the zoo. And then we move them from that habitat to the penguin habitat as the fish population in the penguin habitat depletes. We count the population once a week, and we really think about it like a reservoir that gets stocked, which happens all over North America. Reservoirs are stocked primarily with trout for anglers, and they're monitoring that population and stocking as needed. So that's how we manage this habitat. So they're holding space. Their initial habitat is connected to the penguin pool system. So it's all the same water. So when they transfer from one to the other, there's no change in pH, there's no change in temperature. So we avoid any of the physiological challenges for fish of those changes. They're also moved into the penguin habitat when there aren't any penguins there. Every morning, for the first couple hours, the penguins are pretty reliably outdoors in the sun, on land, basking in the sun as a flock. And that's the time at which we move fish from one space to another. Then they have time, an hour, 2 hours, 3 hours to navigate those pools without predators present. We brought in divers to dive into the habitat and create trout hides. We looked at the types of environments they're using in nature. They're hiding in rocks and logs and thick grasses. And so we installed all of those things, artificial rocks and logs and grasses, to create places they could go to easily evade penguins all throughout the pool system. So those are some of the major considerations that we put in place for the trout. And then we also observe trout behavior too. We're measuring the survival rate, we're measuring how fast they're growing, we're watching them evade penguins. Not only are all those things important through the lens of the consideration of the fish, but they're also important for the penguins. The part of what accounts for the penguins spending so much time in the water hunting, and what accounts for the complex repertoire that they've developed, is that it is very hard to catch trout in a pool that's arranged for the trout's success. If we put 50 rainbow trout in a bathtub, it does not produce this outcome. The trout are easy to catch. 10 minutes later, the trout are going to be gone. And we would be unlikely to see this kind of long duration or complex repertoire that the penguins have developed, because the challenge wouldn't be there.
I also like just the tidbit that did you say the size of the trout that you put in?
Yeah. So we put in trout that are between 4 and 5 inches long. Initially, those are the trout that are most likely caught by penguins. They're also the trout that are most efficiently killed by penguins. So penguins stun those trout instantly when they catch up to them, and then they eat them quickly. So there's not a prolonged suffering going on for the fish when it's caught by the penguin. So we consider the size of the fish with that concept of or that observation that the penguins kill those fish more efficiently than fish of larger sizes.
Awesome. Thanks you, Susan, for bringing that up and making sure that we talked about that. Shout out to Jeremy Dillon for saying we're not done yet. Rick,
Yeah.
I'd also love to hear the elephant example that you shared with us in Australia earlier this year. Could you share a little bit about some of the work you've done there?
Yeah. Like I mentioned before, I started observing our elephants in between keeper interactions. And what I noticed was that they were spending a lot of time engaged in either repetitive behavior patterns like swaying or pacing, or waiting, just standing at the gate closest to the barn where the keepers spend a lot of their time, and not doing any other behavior, just standing facing the barn and waiting for the next opportunity to interact with keepers. So we started to look to that, the freely available environment. What is the habitat providing for them? And like Susan mentioned earlier, we're looking to nature to get some information about which stimuli we want to make available. Hal Markowitz, sort of the father of environmental enrichment, wrote in the 80s that nature provides us a blueprint for an exciting habitat. And Susan mentioned Skinner's insights that, animals appear to have inherited a susceptibility to influence by particular stimuli. Their behavior is likely to be impacted by particular stimuli. And those stimuli, we're going to find them in the wild environment where these species have evolved. That makes sense. That's the environment where they've evolved that tendency to have their behavior influenced by those stimuli. So we look to what they're doing in the wild. What are they interacting with? How are they interacting with it? They've also inherited a physiology, a body that works in particular ways. The penguins have inherited a body that is prepared to swim fast. They still have to learn how to swim fast, but they've got the body for it. They're definitely prepared to acquire that skill. So we asked those questions about elephants. What are elephants doing in the wild? What are the most important stimuli in their lives? What are they working hard to get? Where do they allocate the vast majority of their time budgets? And how do they use their body? How do they use their trunks and their tusks and their feet to interact with the environment to produce those reinforcers? So in sort of an oversimplification of elephant life, we boiled it down to a few things. Elephants interact with other elephants. Elephants eat trees, and elephants interact with the earth, with dirt and sand and mud. The two sort of easiest things for us to arrange were we felt mud and food and trees. So that's what we pursued. We provided robust mud wallowing opportunities. They've always had mud in their habitat, but we enhanced it. We made it much larger. These mud wallows are maybe 30 feet, 40-foot diameter mud puddles. We add literal tons of soft dirt and water. So we're making this really nice mud hole for them to interact with. And then we provided them, like Susan mentioned earlier, we provided them nearly whole trees. So we were already feeding them browse, the leafy branches of trees, and we were feeding them occasional logs, the actual tree trunk. But we started working harder to acquire more logs. So these are 18-inch diameter, 12-foot long tree trunks, and they're covered in bark, and the elephants eat the bark. So we fill the habitat with logs, along with other feeding opportunities, produce, leafy branches. We've made numerous mud wallows throughout the habitat, and we arrange that yard in that way, that outdoor space in that way, and then the elephants go out and they can choose what to interact with, how long to interact with it, how to interact with it. It takes them multiple days to get all of the bark off of those tree trunks, which is important because they don't deplete the resource quickly. So they can eat for a while, and then they can choose to go and wallow, and then they can choose to come back and eat. Oftentimes in the zoo environment, when there's an opportunity to eat, the animal eats, and all of the food is gone. So then they can't come back and eat again until a keeper comes by and provides the next opportunity to eat. So that's something that's I'm starting to understand more and more, that part of this free operant arrangement is engineering ways to offer these opportunities that are not quickly depleted, so that they can choose to interact, go do something else, and then come back again. And it's still there. They're not having to wait for the next presentation.
Which of the free operant freedoms gets ticked by this arrangement? Let's connect those dots.
Self-pacing was my choice. My mind was in exactly the same place, and I'd gone back to my notes to view which freedom was being contacted then.
What other freedoms?
The freedom to form response, freedom to repeat, and speed. All of them.
Yes, that's a free operant environment. Well done, Ryan.
Yeah, beautiful. And that's where the dot connection happened. It was this environment that we arranged, and we observed that elephants spend very little time, if any time at all, performing repetitive behavior patterns or waiting at gates in the presence of this arrangement. And we measured it over several months' time, and we checked back in a year later, and we checked back in a year later. So we're looking to see if it has lasting effects. Does it wane? Do they go back to waiting at the gate after it's been available for a long period of time? And that's not what we've observed. They continue to interact with it as long as we make it available, as long as we provide logs with bark and we keep up on the wallows. They continue to interact with those things. And it was in describing this intervention that Susan made the connection to freeing the operant.
Gratitude to you, Rick, for sharing all of that, and gratitude to our listeners for staying with us to this point. I know this has been a bit of a longer episode than we normally record, but I am biting my tongue to not make it even longer. So for our listeners, Rick and Susan, who are always eager to apply what they learn, we want to build our listeners' knowledge. We also want to build their skill and their confidence in using what they learn from this podcast and practically applying it. And to wrap up, your final thoughts, how can they translate all of this theory, all of the things we talked about today into action? What is some takeaways that you can share, how they can best use this knowledge to meet their animals' needs better?
Maybe I'll answer by describing the way that I'm starting to use it, and see if that gets us where we want to go. I'm looking for identifying what are opportunities that are likely to be important to this individual, partly because of what they are, what species are they, but also what individual history do they have? What's likely to matter to this organism in front of me? And how can we arrange those opportunities in ways that are freer, that are not under complete control of the teacher? And part of that, a big focus lately has been just trying to engineer opportunities that actually last. So two that are interesting, two aspects of that are interesting is one, reinforcers that don't satiate quickly. So Susan brought this dot connection up in a conversation recently that if we think about a kid playing with My Little Ponies doesn't satiate quickly. So if there are My Little Ponies freely available, we see hours, I see it every day in my house, hours and hours of interaction with these toys. It doesn't satiate quickly. So that's an interesting characteristic. And then also arranging so that it doesn't deplete quickly. This is a challenge we're addressing with giraffe. I want to engineer an environment where foraging on leaves is a free operant. They can choose when to eat, how long to eat, how to eat. They can choose to go do something else and then choose to eat again. But it's very difficult to provide leaves in a way that they don't consume all of the leaves rapidly. So then they just eat all the leaves you've provided and they go off to do something else. and they can't choose to come back to leaves. There are no more leaves. They're gone. A lot of our typical environmental enrichment applications in zoos, in my observation, reflect discrete trial training a lot more than they do a free operant arrangement. They're keeper controlled, keeper delivered. The animal engages with them as soon as they're presented, depletes them completely, and then is waiting for the next trial. So we're testing different types of feeders that we can set up an environment like that elephant environment for giraffe, where for the next 4 hours, there's going to be leaves available, and there's going to be water available, and there's going to be other giraffes available, and they can choose how they interact with those different stimuli. I don't know if that got at your question.
It absolutely
exactly,
did. It
but
absolutely did.
Great.
Susan, your thoughts, please.
Wrap up thoughts,
and maybe to the thoughts. The wrap up thoughts are focused on the listeners, and one thing that you would like to share to wrap up that they can take away from this today to start to practically apply in their work, and maybe I'll add to build on Rick's answer there a question. Something that we talked about earlier is knowing when to reach for discrete trials or free operant.
Yeah. So in response to that, I think it depends on whether we're talking about discrete skill building, in which case discrete trial teaching makes sense. When I'm going to shape a particular behavior with the reinforcers I have in my training pouch. I'm going to build the program. I'm going to talk about antecedent arrangement to make the right behavior easier or more probable. And I'm going to shape with approximations to get to the goal. Once they have those skills, then some of them will always only be asked for in a discrete trial environment, like to present a hip for an injection. But we know that when animals learn these discrete skills, they are then part of their available repertoire when they're set into the free operant environment. So I think we would be remiss to consider these as silos, but really that the discrete environment where we train necessary behaviors and the free operant environment are constantly swirling, interacting together to inform one another. By inform, I mean to answer the question the animal has, that we all always have, is how can I use my behavior to access reinforcement and to escape aversive stimuli, So I think that there are times when discrete trial training is essential. Rick and I often admire Jerry Crichton from the Dublin Zoo, who was also one of the collaborators with us, probably inadvertently, although we've thanked him often enough. He brought us the idea of borrowing animals. He'd be great for a podcast as well, with his elephants, borrowing the elephants for the behaviors we need to keep them safe and healthy, and then turning them back into their herds. So he has a unique situation in that he has a herd to turn animals of various ages and stages back to. And it's really been a model for us to rethink what we're doing. So when we say, well, what was the origin thought for us? We would say maybe it was Skinner, and then it was Lindsley, and it was Jerry Crichton, and it was Jeremy Dillon, and it was Jason Breedall. And, it's a full stash of collaborators. His idea was unique. When he first said it to me and we were in the Cheyenne Mountain Zoo barn, I was like, borrow them from the herd, give them an injection, and then turn them back to the herd for the herd to teach them what they need to know and experience. Phenomenal seed was planted with that conceptualization. And he might talk about Alan Rucroft. I mean, I don't think it's a winning proposition, nor is it very reinforcing to us to find the person who invented something, Much more fun to have a gang around and to value and appreciate them. And then just as wrap up, I guess I want to say something about how hard it is. These ideas and our expanding understanding and our tests and arrangements, our asking for money and other resource, reading the article. Everything is hard on this planet, I think that it is hard, what I want to say here, Rick, And so the expectation that we go into this with, and we talk about this often as well with our child rearing and so forth, is it's hard to become an expert, at anything. It takes a lot of hours, a lot of work, a lot of persistence. And when you love your subject, as we four love talking about learning and behavior, then it's not work in that sense of it being a burden, but it's always hard. So we never pick up an article without reading it twice, 3 times, 4. I mean, every time we read it, we expect that we will not get everything from an article on one read. I don't think it's possible. I don't think we have the learning history to be able to gobble them up like that. So I just wanted to share with everyone that when hard becomes a reinforcer, then work is fun. And that's what we're always trying to impart in our students too, is that, is it hard? Yes, let's celebrate. And then we know how to tackle hard. We arrange antecedents to make it easier. We do it in approximations, We read 1 page a day and go have a big bowl of ice cream contingent on having finished the page. It's not, I don't know anybody for whom it isn't hard. Be an interesting interview question, to ask some of the real masters, Joe Lang, Jesus Rosales Ruiz, Christy Alligood, is it hard? And I suspect the answer is it's hard a lot of the time. So I just want to share that with you, because to capture all there is to capture about this and to move where the information starts to move us is a very rocky path. And we just clear those rocks together. And we don't give up on one thing because we found the next new thing. We're very careful to string it together to enrich our pot of tools and understanding. Yeah. So that's what I wanted to share, is just listening to both of you, thinking how much expertise you both have. And I've known you both since you started in this field. And I've watched you embrace the hard. That doesn't deter you. It just makes you break it down and work through it. Call a friend. You know how I talk about Jeannie. I never go to a podcast without mentioning his name at least once. Brian, we didn't talk about the relevance of the cumulative recorder to the free operant environment. So we'll save that for another time.
Well, I was going to say there's no time like the present. We've gone this long. Do you want to?
What's that?
I was going to say there's no time like the present. We've gone this long. Do you want to just briefly mention it?
Oh,
briefly.
Well, I can do. And again, Rick, you help me, because these are big stories, Well, they are for us anyway. We'll condense them down. But I think that people in the field would agree largely that the 2 things that Skinner really broke loose that enabled us to know what we know about how behavior works is this notion of a free operant preparation. That is the chamber where animals can freely move about unrestricted. And then we can select the behavior of interest, the lever pressing or the pecking behavior. And then with that, inextricably comes the measure that he invented, as far as I know, is called the cumulative recorder. So instead of recording how much salivation is produced by the sound of the metronome, or how fast in time measures the cats let themselves out of the box, we're just going to put a pen down on a piece of paper, and every time that rat presses the lever, we're going to add increments, that lever pressing frequency, so that the measure is an accumulation of every lever press. So you're seeing an escalating line. To measure frequency of behavior, in the time that the animal was in the chamber. So it becomes rate. And every time a reinforcer is delivered, a little slash is put through this escalating, growing, cumulative line depicting lever presses. And that's how the schedule, the known patterns, the predictable patterns of schedules of reinforcement emerged. So without this line escalating every time the lever is pressed, I'm showing an angled line on a graph and showing the different schedules of reinforcement for those lever presses, either continuous or intermittent. We didn't know that our behavior is conforming in terms of our pattern of behaving to the schedule of reinforcement we're experiencing. So this cumulative recorder was critical in measuring the operant behavior freely available in the chamber. And the two together are like the perfect protein to crack open the case of how behavior works, how the environment influences behavior. That's not to say that emotions don't and thinking behavior does, or ethology or your genetics, your nutrition, your brain, all of that are our science siblings that bring the jigsaw puzzle together. But the piece of the puzzle that Skinner broke open was broken open as a result of his free operant chamber preparation and this recording frequency or rate cumulatively instead of in these discrete trials. The rat finishes the maze, count how fast and how many errors. The cat comes out of the box, count how fast on repetition. Or the dog is strapped up, count the volume, the speed to which they salivate to the metronome and the volume and the chemical property differences from whether it's elicited by meat and mouth or by the metronome. So these were breakthroughs in understanding the science of behavior change. And I sent Ryan a photo, which you're welcome to share. And I sent Rick at the moment it happened because, oh my goodness, how lucky am I to have Rick and my family to share these exciting moments with. Carl Cheney came to dinner the other day, my mentor who's almost 90. And when he left, he went into the car and pulled something out. And with his big grin, he just bestowed a cumulative recorder to me. And Neil took photos of me screaming to have a real live Gerbrand cumulative recorder from days gone by. It's all computerized now. And so the lid was broken. Neil fixed the lid, and now it's sitting prominently on my in my living area. And now we'll see how many people look at this thing and say, "Hey, what is that?" I guarantee no one, except you guys from this community, would you come and visit and say, "What is that?" This piece of metal is sitting there, and it's got the rollers so that the paper rolls through it. And every time the rat would push the lever, the needle moves up another notch as the paper is rolling underneath the needle. Phenomenal. So look up cumulative recorder and connect the dot between that and this free operant chamber, which now elects us to connect the dot to improving the lives of animals in human care.
Amazing. Love the photo. We'll share it with this episode.
Okay. It's very exciting. It was Christmas.
Thank you, not thank you, everyone. Thank you, Rick and Susan, for sharing. Thank you, everyone, for listening and sticking with us for this hour and a half. Rick and Susan, for those who might want to learn more or check out the resources that you have available or get in touch for collaborations, where can they go to find you and get in touch?
The Behavior Works website.
They can find us there. Our email interfaces are there. And you're welcome to, that's probably the easiest way to just go there and look on the consultants page for Rick's link to his email. And my email's on the front page, as I recall. And we're happy to be in touch. And we're just so proud. We're so proud of you all to even have a platform to have this conversation. We're never alone when Ryan is willing to say, would you come and talk about that with us? Absolutely. It's a wonderful, super
It's
reinforcing.
phenomenal.
Yeah. So congratulations to you all. Anyone interested in this hour and a half, they're welcome at our table.
Well, I think this will be roughly around episode 210. And I think it's one of the ones I've been the most excited about to record. So I'm thrilled that we got to do this. We will link to everything we talked about in the show notes. This has been so much fun from myself, and on behalf of everyone listening, Rick and Susan, we really appreciate you taking the time to come on the show today. Thank you so much.
Thank you.
Thank you.
And thank you as well so much for listening. This is your host, Ryan Cartledge, signing off from this episode of the Animal Training Academy podcast show. It's our hope today's conversation sparked inspiration and added some tools to your trainer's toolbox. Remember, every training challenge is an approximation towards becoming a better trainer. Embrace the rough patches, learn from them, and keep improving. And don't forget, the path to growing your skills and expanding your knowledge continues beyond this episode. Visit www.atamember.com to join our waitlist and be the first to know when our membership doors open again. There you'll find a supportive community of trainers just like you, working to make a positive difference in the lives of animals and humans alike. Until next time, keep honing your skills, stay resilient, and remember, every interaction with an animal or human learner is your opportunity to create ripples. We're here cheering you on every step of the way. See you at the next episode.